DO mixture preparation that can be used in the production of alcohol and fuel ethanol from grain raw materials. Known methods of automatic control of the DO preparation process were based on measuring on consumption of raw materials and the concentration of DO and regulating the water supply. We offer an improved method based on robust stabilization, non-linear process control that will ensure a more stable operation of system, smooth transition of regimes and economy of used energy, improvements of quality of the mixed DO as well as final ethanol product. The optimal operation modes of the installation were investigated using state-space dynamical modeling technique and ethanol production process simulation. From 2007 to 2008, share of ethanol in global gasoline type fuel use increased from 3.7 to 5.4%. In Ukraine, today, in the condition of the military aggression and war against Ukraine, and in view of issues of energy security and stable function of the fuel market, this initiatives are gaining special relevance. Therefore, fuel ethanol is considered one of the most important renewable fuel due to the economic and environment benefits of its use. It is the most promising feedstock and producing bioethanol due to its global availability and to the energy gain that we can obtain from biomass and used for cogeneration of heat and power. We developed automatic optical control of the production process of DO mixture preparations that can be used in production of ethanol from grain raw material. Known methods of automatic control of DO preparation process were based on measuring consumption of raw materials and concentration of DO and regulating the water supply. We offer an improved method based on robust stabilization nonlinear process control that will ensure a more stable operation of system, smooth transition of regimes, and economy of used energy, improvement of quality of the DO as well as final ethanol product. According to proposed method, the concentration of raw material is determined and the regulation of water supply is carried out according to a non-linear law. It is developed several process configurations for fuel ethanol product from where studied using state-space dynamical modeling technique and process simulation. Production device consists of pre-boiler mixer 1, into which grain of a given rate and concentration and water of known rate are supplied. Device consists of multiplication block 2, which receives measuring current values of flow rates, added to which resulting signal is applied and signal corresponding to the target value of the mixture concentration is subtracted division block 4, where output signal from block 3 is divided into a signal corresponding to the current value of the mixed concentration, added 5 into which resulting signal from division block as input control valve 6, which changes water supply to the mixer, the position of which is controlled by the resultant added signal. To ensure homogeneity of the mixture, it is mixed which a propeller steerer. The purpose of boiling raw material is to release stretch from plant cell and convert stretch into a soluble state. Modeling method allows you to avoid big mistakes during the implementation of production and accelerate its development. Many processes cannot be studied in industry devices due to impossibility of arbitrarily changing their mode of operation. Main results are we develop robust control strategy on the minimization of the energy efforts of ethanol production plant and in the presence of small state perturbation of states from the position of equilibrium. To solve this problem, we consider the space state model technique. This model includes linearized equation and full feedback taking into account nonlinearities. In order to choose the correct response, a control selection center used mechanical states to select amount of responses necessary to counter the disturbance. This center evaluates difference between an estimate state and decide state and choose appropriate trajectory and feedback gains. Control selection center effectively choose appropriate grain metrics. Motor control system is measurement to receive a desired state vector from experiments, compare it with measured state, and generate control commands. The design objectives are following: regulation of the state to their respective set point determined from experimental data were obtained from biomechanical tests conducted with aid of motion tracking software OptiTrack with dedicated software. We use LQR regulator in order to select trajectories that minimize an objective function which widens the deviation of the control and state from nominals. Our goal is choosing approximate Q and R matrix, and we use numerical methods of MATLAB for solving it. This is described in more details in our paperwork. Model experimental data were taken from an ethanol production installation used at most plant in Ukraine. Necessary experimental tests were conducted in real time in order to provide the further analytics in MATLAB environment. And MATLAB experimental testing in order to perform an analysis and obtain real data from control law simulation as reference values. The experimental testing was conducted and data analysis was spent, figure 3 and 4. You can see figure 3, from which reference values of consumption of grain and water were taken, collected, transformed, analyzed, converted into appropriate units, and then are used for controller simulation. Using available MATLAB tools, CF tool data analyzing, we calculate reference values of system states according to given experiments. To do this, we use MATLAB fitting toolbox And in order to build approximate lookup table for controller evolution, series of experiments were conducted. Controller takes initial and reference values from preliminary experimental data collected in appropriate lookup table, and for this we select reference values. We use MATLAB function OUT45 for system simulation and control system toolbox to solve Riccati equation. With aid of function care of MATLAB, we compute solution X of the Riccati equation. Rendering the state and control to the reference values, we manipulate and widen matrices R and Q, and they can be chosen so as to penalize excessive exertion of control inputs and desires the reference state variable, desired values of volume and liquid in tank and the mixture concentration respective. The resulting controller trajectory is shown on figure 5 and figure 6 for current values of volume of liquid in the tank and for current mixture concentration value. Resulting controller state variable value volume of liquid in the tank is shown on figure 5. Solution, some solution, and state variable mixture concentration on figure 6. Conclusions. In this paper, we have developed automatic optimal control of production process of dough mixture preparation that can be used in the production of alcohol and fuel ethanol from grain raw materials. The developed improved method based on robust stabilization nonlinear process control that will ensure more stable operation of the system, smooth transaction of regimes and economy of use energy, improvements of quality of the mixed dough as well as final ethanol product. We can see desired state and their good model realization based on LQR control technique. Control gain obtained in the presentation simulation experiments demonstrate a graceful trajectory, degradation, and minimal energy and control effort. Optimal operation modes of this installation were investigated using state-space dynamical modeling technical and SNO production process simulation. Thank you for attention.
Thank you very much. Thank you. Dear colleagues, are there any questions from the conference participants? So I have some question. I have one question. Question: how are the values of characteristics presented by you obtain it? These characteristics which you used in mathematical models in MATLAB, how are you obtained? It is experiment. It is maybe MATLAB emulation.
No, in most it is MATLAB simulation, but we
Okay, it's MATLAB simulation, and when we used MATLAB simulation, you can take these characteristics. Understand it? It is.
We compare digits from MATLAB model and with real in our city. So
it is experts date. It is expert days, tak? Yes.
Yeah.
Oh, okay. Thank you very much. Sorry. Next report. Plan.
Sorry, I think there is someone trying to ask.
I have a question from Gennady.
Sorry.
Good afternoon, colleagues. If I understand it right, in your process, you obtain two products. First one was ethanol for fuels, and second one was alcohol for drinking, I think.
It is question to Roman Grudetsky. Yes. Thank you.
What about the test of alcohol obtained by your process?
Thank you for your question.
Can you repeat, please?
You have two products in your controlled process. If I understand it, first of product was ethanol, and I understood that ethanol was destined to fuel, and second product was alcohol. Yes or not?
We get ethanol that we can use in various industries, including fuel production. So we get ethanol.
Ethanol, not alcohol.
Yes, ethanol, not alcohol.
Okay, thank you.
Thank you very much. Dear colleagues, have a question? Thank you, Roman. Thank you, dear colleagues. Next article is Nina Kalinin in this conference. No, sorry.
No, Kalinin. Our speaker will be Vitaly.
Vitaly Kolodnenko.
Yes.
Vitaly Kolodnenko.
Share your screen, please.
In conference. Can you speak? Can you show your slide?
Yes.
Vitaly, can you see? Can you show? Or you have some technical problems?
Maybe Vitaly will be next.
Thank you.
Let's see.
Yes.
You can continue.
Thank you, Vitaly. Next article, Yevhen Kalinin, Vitaly Kolodnenko, Anna Szyman, and Nina Kuchuk. Synthesis of the theory of motion of solid bodies filled with bulk substance for fault-tolerant identification of their parameters. Vitaly, we cannot see. We cannot see
See your screen. Please
your.
share your screen.
Can you open your slide? No. Starting and finish.
Okay. Maybe Vitaly, we will decide his technical problems, and we will go to next one. And after this, report will be Vitaly. Okay.
Can you open, Vitaly? Can you demonstration? We can hear see. We can hear you. No. We cannot hear. We cannot see your slide.
Не может включить, Саня, блин, свет включи.
Okay, Sergey Gennadievich, I think we go to next report, and
Okay,
Vitaly
understand.
will be engaged.
Thank you very much. Vitaly, you can do your report next in next slide, in next report, after report. Okay. Thank you. Vyacheslav Ivanenko.
Yes, I'm here.
Vyacheslav, can you show your slides?
Yes, I try to show. Okay, I can start.
Yes.
Thank you. Good afternoon, dear colleagues. I am excited to provide innovative studies on the predictive potential of social media data, particularly Twitter data or X.com, in anticipate stock market moves. The title of the research project is Assessing the Informative Value of Social Media Data in Stock Market Prediction, Financial Sentiment Embedding Approaches. The presentation will go into reason for the research, our aims, the advanced methodology I used, the relevant outcomes we can see, and concrete case studies, and lastly we will connect everything together with our conclusions. Motivations and state of the art. In today's digitally linked world, platforms like Twitter have evolved from ordinary social interaction sites to powerful conduits capable of influencing financial markets. Consider this, millions of tweets are sent out every day, some of which includes critical information about financial markets. But how can we find the valuable information in this large flood of information? Previous research looked at Twitter abilities to influence financial indices. But this work goes further with the goal of harnessing this potential systematically. Next slide, state of the art. Several researchers have tried to understand the impact of social media on financial markets. However, while they are laying the groundwork, I tried to construct the infrastructure for this process. This research not only highlights the importance of Twitter data, but also proposes a novel for properly exploiting its actual value. Objectives of the research. The goal was very simple, to effectively use the huge amount of Twitter data for stock market forecasting. This wasn't simply about collecting data analysis. I aimed to filter, evaluate, and incorporate thoughts from tweets in order to fully understand the market moves. Short methodology overview. The strategy was complex. First, I realized the necessity for a solid mathematical model that could take into account the specifics of the Twitter data. Then I used zero-shot learning. Its innovative approach that ensured our model only analyzed the most relevant tweets. At last, I invited to extract the substance of market segments from these tweets using a novel embedded approaches. Data preprocessing, the main step in this model. Dealing with something like Twitter requires dealing with massive amount of data, which is often disorganized. To cut short the noise, I started by utilizing the customized Twitter validator. The data was then standardized, ensuring that our model had a consistent dataset to work with. Furthermore, I developed techniques for detecting and dealing with outliers, ensuring that our results, these results, were not biased by abnormalities. This is short schematic representation of the tweets validator model. I use large language model for zero-shot classification. I use some keywords like stocks, investment, economy, trading for understand relevant input Twitter text to this field. So next, modeling and analysis. I started with basic IMAX model, a tried and true financial forecasting tool. The enhanced model, a hybrid